So to wrap up our ionic bonding, let's look at the Lewis dot application with ionic bonding. Our steps are to first fill in the missing information in this chart. So I'll do an example with you. Sodium has 11 protons because its atomic number is 11. It doesn't say that it's an ion, so that means it has 11 electrons. The number of valence electrons comes from my family number. Sodium is in family 1, so it is 1 valence electron. And the number needed to fill its outer layer, well, it would either need to add 7 or lose 1. Well, what's more likely going to happen is it's going to lose 1 because that's much easier than adding 7. So let's just put lose 1. You'll fill out the rest of the table just the same. Next, for each of the following ionic compounds, meaning these, A, B, C through F, write the formula for the compound to find out how many of each element are in the compound. Next, we'll write the symbol for each element, draw the Lewis dot for the valence shell of each element, draw an arrow or more to show the transfer of electrons, and then write the name of the compound. So I'll do one of these with you. How about B? Magnesium with iodine. Well, my first step was to write the formula. My formula for magnesium, Mg with iodine, I. Magnesium has a 2 charge, iodine has a 1 charge, meaning I need 2 iodines to balance out the 1 magnesium. The next step is to do the Lewis dot of each, and then use an arrow to show the transfer. So I need 1 magnesium and 2 iodines. And I need to represent the Lewis dots, so the number of valence electrons. Magnesium has 2 valence electrons. Iodine, if we look at our family numbers, starts with 7 each. When these elements approach each other, the electronegativity of iodine is much stronger than the electronegativity of magnesium. Electronegativity is the ability to attract an electron. Therefore, iodine can easily attract this electron from magnesium. So this iodine approaches and easily attracts this electron from iodine, and it is transferred to here. So I draw my arrow to show the transfer. However, this will fully satisfy this iodine. This iodine will have no more locations to attract an electron. So while it is still more electronegative, it doesn't have a location to pull in a new electron. Just like a noble gas has no electronegativity comparatively because it cannot pull in any more electrons. And electronegativity is the ability to attract an electron. Once this iodine has attracted this 1 electron, it can no longer attract any more. Now, where 1 iodine is, there must be more atoms of iodine floating nearby. So another iodine comes near. It attracts the 2nd electron from magnesium, and that will transfer here. Now, to represent the change that happens after these electrons are transferred, we show each of the Lewis structures that now with their charge. So now, big arrow to our new results. We have magnesium that has lost 2 electrons and is therefore now 2 positive. Then we have an iodine that has gained 1 electron, but we need to represent all of its Lewis dots now. It has 8 valence electrons, and now it has a -1 charge. And we have a 2nd iodine that has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And because it has also gained an electron, it is also a 1- charge. All of this together shows what has happened through this movement of electrons that has created these ions, and now these ions are stuck with one another. They're attracted to one another. The compound name would be to first name the metal, magnesium, We name the cation or the metal, then we name the anion or the nonmetal. In this case, it is iodine, which we trade the ine for iodide. So it's I-D-E. Your homework is to complete the rest of this page, go through the entire packet, all of Unit 2B, checking every blank, every line, every question. Make sure the entire thing is complete, and then start working on your review for the test on Thursday. Tomorrow we will do a review activity in which you will need to apply all of the information you know about the periodic table to an alien periodic table, to identify elements using names that you don't know, but they still have the same properties of the elements you do know. Make sure you know your diatomics, all of your periodic trends, your alkali metals, your families. All of this is very necessary in order to do well on tomorrow's activity, which is for a grade. Your test is on Thursday, and you should be studying and seeking help for anything you're struggling with.